Hello, this is Prathamesh Patil and welcome back to my YouTube channel. Today we'll be looking at the one of the most popular questions from Leetcode, that is two sum.
Coming on to the question, let's see what the question says. So we will be given array of integers, that is nums, and a given target, given integer target. So we have to return the entire indices of two numbers so that they add up to target. So yeah, so let's consider an example like this. 2, 3, 1, and 4. And suppose the target we are supposed to have is 6. So by visually looking, we can see that addition of 2 and 4 adds up to 6. So we have to code this, right? So let's see what the question tells that there is exactly one solution to it, and we should not be using same elements twice. Like if the target is 3, it is also possible to achieve it by 3 plus 3 is 6, but it is on the same index, so we cannot achieve this. Right. So let's move on to the approach first. Now, moving on to the approach, what we can do is directly take two for loops, simply from 1 to n, and another one from I plus 1 to n. So what this will do is basically this will here will be checking ARR of I. So this is of I and this is of j plus ARR of j is equals to target. This will check in the if condition. If this is achieved, then we'll just return I, comma j. Right. So we'll achieve this by two for loops. But considering this question, we should also be looking at the time complexity. So for this question, this solution, time complexity comes to O of n square. As there are two loops, this one and this one. So this will run n times, this will run n times. So that will be total of 4 n square. So what can be the optimal approach for this? So let's look on to the optimal approach. Now, just think that if we just calculate, suppose, let's consider the same example again, 2, 3, 1, and 4. So what we'll be doing is, we'll just consider this example. For this approach, we'll be calculating the needed value. Now, what can we define this needed value? So this needed value will be equal to target minus ARR of I. That is the number which we are on the iteration. So we'll be using the concept of hash mapping here. So how we'll be using hash map? So we'll be, suppose this is a hash map of key and value pair. So this is the key, this is the value. Let me just write this once again. Our array here, 2, 3, 1, and 4, and our target is 6. So what we'll be doing here is we'll just in the iteration we'll go on to the this position, 0 position. So we'll be storing the key as 2 and value as 0. That means this will be representing. That means here the key will be representing the value and the value will be representing the index. So this is a key value pair hash map, right? Now for the first iteration, uh, we have inserted this 2 and 0. Now what we'll be doing is we'll be calculating our needed value. Needed value. So what is our needed value? Target minus ARR of I. So here the needed value will be something like 6 minus 2, that is 4. So this value will be checking in our hash map. So is there any 4 value in here? No, right? So will be moving forward. Now we are on index 1. So we'll be inserting that thing 3 and 1. Right. Now we'll be calculating the needed value. So that will be 6 minus 3 is equals to 3. Now 3 is there here, but we'll be using this 3 twice as this is only on one index, right? So as we are on ith index here, I is equals to 1 and even the index stored is equals to 1. We cannot have the same index elements twice, right? So let's move on to the next thing. Just clear this up. Yeah, I'll be on the index number 2 from zero based indexing, right? Now we'll be inserting 1 and the index will be 2. So yeah, I'll be checking. Here we'll be checking 6 minus 1, that is 5. So if 5 is there in here, no, it's not there. So we'll be moving forward. Now we'll be on the last index, that is 4. So we'll be inserting 4 and so index as 3. Now we'll be checking 6 minus 4 is equals to 2. So we'll be checking 2. Yes, we have it here. That is, this is when we'll return these indexes. These indexes 0 and 3. Now we can return them in any order, so it's not an issue if you also return 3 or 0. So this is the approach. Now the main thing that we'll be watching here is the time complexity, right? So what will be the time complexity of this code? This whole process will be getting executed. The time complexity. Time complexity for this code will be O of n. Now why O of n? Because we'll be considering one for loop from 1 to n, and simultaneously we'll be checking if our hash map contains the needed value. We'll be doing this in this for loop, and simultaneously we'll be adding the values to hash map, right? So this whole process will be taking off in time complexity, and this can be said as optimal approach. And one more important thing, when we'll find this needed value in here, we'll be using the return. We'll be returning both the indexes, that is I and the index from the map. Simple. So this is the two sum problem. This is quite famous. Let's move on to the coding part.
So yeah, we'll be looking at the code now. Let's just create a dictionary first to store our key value pairs. So we'll name it as map. This is our dictionary to store the value and the index. Now we'll just iterate once through the list of nums that is given for I in range 0 to length of nums, right? So here you can use enumerate as well function to directly separate the indexes and the value of integers in nums, and we'll just calculate the needed value. Needed value will be something like target minus nums of I, right, as we discussed previously. So we'll be checking this needed value if needed value is present in the map, then we'll return the list of integers, that is I, and the map of needed value. That means we'll be returning the index of this needed value from the map that we have stored previously, right? Now we'll be updating the map with the nums of I equals to I. That means we have inserted the value with its index as key value pair. Okay, so this should work. Let's see what happens. Yep, it's accepted. Let's check it out. Yeah, it's done. So this is how you can do this in one for loop with time complexity of O of n.